In comparison to old technology aircraft, the flight deck on the A320 is designed to be a comfortable, uncluttered environment in which to work. By using modern electronic display units, the presentation of information to the pilots has been improved. The Electronic Instrument System, EIS, consists of 6 identical full-color cathode ray tube display units. The EIS is divided into 2 subsystems. The Electronic Flight Instrument System, EFIS, for which each pilot has 2 displays. The Electronic Centralized Aircraft Monitoring System, Ecam, which uses the 2 displays in the center to provide information on the aircraft systems. Let's look at the EFIS system first. Flight parameters are displayed on primary flight displays, PFD, while navigation data is displayed on navigation displays, ND. Outboard of the PFD, there are control knobs to adjust the brightness of the associated PFD and ND, or to turn the display off. A switch is provided to allow the information on the PFD and ND displays to be transferred. The use of this switch will be explained in the EIS reconfiguration module. The 2 displays in the center are dedicated to the Electronic Centralized Aircraft Monitoring System, Ecam. At this stage, we will simply introduce the Ecam displays and associated controls. In later modules, the Ecam system will be studied in detail. The upper Ecam display is known as the Engine Warning Display, EWD. The lower Ecam display is known as the System Display, SD. It is on this screen that various aircraft system parameters can be viewed by the pilots. As an example, we will cycle through the system pages for you. The presentation of system information is based on a need-to-know philosophy. This means that only the system information relevant to the particular phase of flight is presented to the pilots. You will see this demonstrated in the normal and abnormal operation modules. Another philosophy that is used on the flight deck is the lights out configuration. What this means is that when the aircraft is in its normal flight state, there will be no white lights illuminated in any of the switches on the overhead panel. As an example, just before takeoff, if you look up at the overhead panel, there should be no white lights illuminated on any of the switches. Let's look at some switches and show the different possibilities. For the majority of the switches on the overhead panel, the push-button switch logic is normal operation configuration, no light showing, the lights out philosophy. Abnormal condition, amber fault light. This assists identification of the switch associated with an abnormal condition. White light. If normally the system should be operating and is deactivated, a white off light is illuminated. If normally the system should not be operating and is activated, a white on light is illuminated. There are some switches on the overhead panel which are used on a temporary basis or may have an indication of their state. The logic is temporary selection for operational reasons, blue on light, for example, anti-ice. Applicable system status, green light, for example, APU available. You will see this philosophy demonstrated throughout the course. Below the Ecam displays on the center pedestal is the Ecam control panel. The two controls on the left-hand side are to adjust the brightness of the two Ecam screens or to turn them off. We will look at the rest of the controls on this panel in more detail later. Just below the Ecam screens on the pedestal is a switching panel for use in abnormal situations to restore data to the Efus and Ecam displays. You will use this panel in the EIS reconfiguration module. In front of each pilot, there are two attention getters, a red master warning and an amber master caution. As a further means of getting the pilot's attention, there is a loudspeaker on each side of the cockpit for oral alerts and voice messages. Note: the loudspeakers can also be used to listen to ATC and the intercom. Now let's go back to the Efus system. For the Efus displays, data from the Air Data and Inertial Reference System, ADIRS, plus navigation data from the Flight Management and Guidance System, FMGS, is fed directly to three display management computers, DMC. The three identical DMCs process the data and generate the images to be displayed. In normal operation, DMC1 supplies Efus information to the captain's PFD and ND, DMC2 supplies the first officer's PFD and ND, DMC3 is available as a backup. You will see the use of DMC3 in the abnormal operation module. Now let's look at the other EIS subsystem, Ecam, and how the Ecam displays get their data. Sensors are fitted throughout the aircraft to monitor the various systems, including system controls operated on the flight deck. Data for certain parameters, for example fuel quantity and primary engine indications, is routed directly from the system sensors to the three DMCs. Note that there are separate channels within each DMC for Ecam and Efus. For the majority of the systems, the sensors supply data to two System Data Acquisition Concentrators, SDAC. The SDACs acquire system data, process it, and send some of it as system page data to the three DMCs. Normally, DMC1 supplies the engine warning display. DMC2 supplies the system display. DMC3 is available as a backup. Two identical flight warning computers, FWC, receive data from the aircraft system sensors to generate red warnings, the SDACs to generate amber cautions. The FWCs then supply the DMCs for the display of alert messages, the attention getters, the loudspeakers for oral alerts and synthetic voice messages. All the components shown can be collectively called the Ecam system. We will study the use of the Ecam system in a separate module. In addition to Efus and Ecam, time measurement devices are provided. The master time reference for all aircraft systems is provided by a clock, located on the right lower side of the main panel. In this example, the time is 13:28. The time is also displayed at the bottom of the system display. Adjustment of the time is achieved by using the Universal Time Coordinated UTC selector and the Set knob. You will have the opportunity to do this in the simulator. The Set knob can also be pressed to display date information in the order month, then day. In this example, the date is July the 4th. There are chronograph and elapsed time ET facilities on the clock. These functions will be covered later. In this module, we have introduced you to the electronic instrument system, with its two subsections, Efus and Ecam, and the clock. In the next modules, we will concentrate mainly on the Ecam system, and then, later in the course, return to look at the Efus displays in greater detail.